Hi, I'm Dr. Tallis Barker from waterfasting.org. I'd like to cover one of the most contentious issues in all of water fasting, and that is the whole idea that water fasting causes muscle loss. We're going to try and disentangle fact from fiction, which in itself is going to be quite a challenge, since really the only way to know what's truly going on is if somehow we could get in there into your muscle cells and see what's going on. We can't. So effectively, we're reliant on indirect evidence, but I do believe that there is enough information based on very clear indirect evidence to come to a conclusion on this whole issue. And rather than just rely on the hearsay of others, I just like to present that evidence so you can make your own decision. So where does this whole idea of muscle loss stem from? Well, I don't think anyone really knows, but one thing is for sure. When you fast, you're going to start to feel weaker. And understandably, if you're feeling weaker, the logical conclusion is that something's going on with your muscles. And I think it's not a huge leap of the imagination to get to the point that you really start to assume that, yeah, the fast must be causing muscle loss. In addition to this, there's another factor, and that is that, as is pretty well known, within 24 to 36 hours after the beginning of a fast, you're going to run out of glycogen, the stored version of your carbohydrates. And yet, if this were the case and there were no other source of blood sugar, you should be running on 0 blood sugar in your blood, but that's not the case. So the idea is that effectively, especially while ketosis, your fat burning mechanism, is evolving over the first few days of the fast, your body is also breaking down muscle tissue to strip the proteins in order to create blood glucose to burn. We'll come back to that later. Another issue that contributes to the whole confusion here is also terminology. Muscle loss. Fasting causes muscle loss, but what does that really mean? We'll come back to that too. Finally, technology plays a very big role, especially recently, in the idea that fasting causes muscle loss. And that is due to the event of smart scales and DEXA scans, both of which, at least seemingly, will come to the conclusion that your body is losing a lot of muscle mass when you're fasting. So now in the next section, we're going to go into that in a lot more detail. Smart scales work through what is called bioelectrical impedance analysis, which is just a fancy way of saying it measures how much resistance your body offers to an electrical current. The reason that this is important is that different tissues will have a different resistance to electricity. Fat, for instance, acts very much as an insulator. It does not let very much electricity pass through it. Muscle tissue, on the other hand, the inner organs, and obviously body fluids will act much more like conductors. So when you stand on a smart scale, it's going to put a very low-level electrical charge through your body, see how much is coming out, and then through algorithms come to a conclusion. From that, you're going to read in a lot of popular press that yes, smart scales will measure fat, muscle mass, and water. Back to terminology, right? So the thing is, if you look at what the manufacturers actually write in their small print, it doesn't talk about muscle loss, or rather muscle mass. It talks about measuring fat, water, and fat-free mass. In other words, the mass which is simply not fat. And that is because smart scales simply cannot distinguish muscle from organs, from connective tissue. So you see, again, the devil is in the detail here. When we come to DEXA scans, that uses X-ray technology. And in a similar sort of way, when you pass X-rays through the body, you're going to light up areas more than other areas. So essentially what a DEXA scan can actually measure is the mineral salts of your bone as one category. It will measure fat as another category. And then it's not measuring muscle mass, just like with the smart scales, although again, you can read about it in the popular press that way. If you actually look at what the manufacturers write, they will talk about lean mass, not muscle mass, lean mass. And that is because a DEXA scan cannot distinguish muscle mass, or rather muscle tissue, from connective tissue, from your organs, or even from body fluids. So again, it's a gross oversimplification when somebody comes back having had a DEXA scan and they're horrified by the amount that the DEXA scan has said that they have lost in terms of muscle mass, because they've not, okay? Consider the fact that when you do an extended water fast, the majority of the weight that you lose is not fat, it's body fluids. Now, if body fluids are being grouped into the same basic category as muscle, organs, and connective tissue, well, then of course it looks like you've lost a lot of muscle mass, whereas all it's doing is saying that the sum total of muscle mass, organs, connective tissue, and fluid has reduced. And the fluid in itself explains everything. Okay, so we can't see inside the body into our muscle tissue to see what's going on for real. We can only make an educated guess. So what I'd like to do now is just consider the possibility that muscle loss in the strict sense of the word is truly taking place. What would happen? Okay, first of all, muscle tissue is pretty important to existence. Without it, you're not going to get very far. So the idea that the body is just going to harm itself is pretty far-fetched. The body is going to do everything it possibly can to preserve maximum health at all times. But really, above and beyond that, let's just assume that in any case, the body is autophagizing, it's breaking down muscle cells, muscle tissue. Well, this would be a hugely destructive process, leading to the influx of huge amounts of toxicity as cells are being ripped apart, and you've got all sorts of junk flowing through the blood. This would create a huge burden on the liver, on your organs of detox. Now in a fast, they're working to full capacity anyway, just dealing with the junk of regular detox, and they would quickly become overwhelmed, leading to pretty horrendous detox symptoms. Okay, above and beyond that though, let's look a little bit more into the nitty-gritty. Breaking down muscle cells and muscle tissue is a pretty big job. It's going to take time when you consider that the immune system cells, which would presumably break down these cells, are teeny weeny. They've got to gobble up masses of cells to produce the baseline of what's going to become sugars ultimately, according to this theory. It would take a long time, and yet this is not what really the clinical evidence shows. When you run out of glycogen, it's not that your blood sugar goes down to zero and now we need to wait for all those muscle tissues to be broken down. No, there's going to be a level of glucose because I believe something else is happening, and we'll come to that in the next section. Maybe even more telling is what happens at the end of a fast. If you were truly breaking down muscle cells, muscle tissue, it's going to take many weeks, if not months, to build back your strength. And of course, anyone who's done an extended water fast will tell you that's not what happens. It's really just going to be a matter of days, or even after a 40-day fast, a couple of weeks maybe, to get your full strength back. So I am utterly convinced that something else is going on here. And as we'll talk about in the next section, I think all the physiological knowledge that we have proves that. So what actually happens for a fact that we know with 100% certainty? Well, let's go back to the whole idea that when your body runs out of glycogen, blood sugar starts going down. What happens then? Well, we know for a fact that one of the first responses to low blood sugar is that the body will increase production of cortisol. Now, during a fast, cortisol is the hormone which allows access to your adipose tissue so that fat and all the versions of fat can start flooding into the bloodstream from where cells will pick it up in order to burn through ketosis. fact, right? Now, the thing about cortisol is we normally think of it as a fight or flight hormone. Of course, in a fast, it's being produced purely by the physiological response to low blood sugar. But especially when we think of it in terms of its fight or flight response, what is the prime purpose of cortisol? It's to mobilize all possible sources of energy so that we can fight or flee from that lion or whatever it is that we need to fight or flee from. Now, that means that not only is it accessing fat, it's also promoting the production of new sugars, and that whole process in the liver. And here's the key, okay? Cortisol also, as the cortisol attaches to the cortisol receptors of every single cell in the body, is basically also going to ask those cells to start donating amino acids. Now, every single cell in the body contains amino acids, kind of like in a storage tank. Amino acids are the building blocks for whatever that particular cell needs to do. As it so happens, muscle cells have the largest storage tanks in the whole body. So when cortisol comes out, and this is physiological fact, every cell will start donating amino acids, muscle cells in particular, and of course, it is those amino acids which in turn will form the basis of what will become sugars through that process of stripping off the nitrogen atom from the amino acid molecule. This is not a destructive process. It's something which happens not just when we're fasting, it happens under all sorts of circumstances. So again, the idea of the body is not going to do anything which will end up harming itself is utterly confirmed here. Now, of course, because it's not a destructive process, it's not going to create a further burden on your organs of detox through added toxicity. Not only that, but if we think about the time scale involved with breaking down whole muscle cells, when it's just a question of cells releasing amino acids, that can happen very quickly, very easily, and it can be really quite responsive to the changing needs of the body as you go through a fast. And this is also confirmed clinically, especially when someone wears a continuous glucose monitor just to see what's going on with their blood glucose levels. It's always going to be fluctuating. And a big part of that is because cortisol levels will be adjusting, and that will have a very quick response time in terms of how quickly amino acids will get into the blood, along with fat, of course. And when we look at the end of a fast, the exact opposite is true when we look at the long recovery time from true muscle loss. We rebuild very, very quickly. We regain our strength very, very quickly at the end of a fast. And that's simply because we don't need to build new muscle tissue. We simply need to refeed healthily in our own good time and allow the natural amino acids in the food we're eating to refill those storage tanks. So finally, again, we cannot see into the muscle cells themselves. That would be the only direct evidence we could have. But there is so much indirect evidence to support this theory that I would like to promote, that it is amino acids which really is the issue here. When we don't break down muscles, there's no need to worry about it. And I really hope that the people who I come in contact who are really a little bit reluctant to fast because they fear muscle loss can give up that fear and just go out there and fast. It's the best thing you can do. I hope this video has given you the information you need to come to your own decision on this issue. Is it true muscle loss, or is it just amino acids from the whole body, and yes, especially from muscle tissue, flooding through the body to get the job done? Remember, the consequences of true muscle loss are entirely different from the, well, let's say, lack of consequences when amino acids are involved. I hope you enjoyed the video. If you did, please hit the like button, and better still, subscribe. If there are any issues I didn't cover, feel free to leave a comment, and I'm very happy to respond. Thanks for watching.